I go to Harmony School of Advancement. In this video, I will be demonstrating the physics concept of center of mass and balancing. What is balancing? How can an object be balanced? And what is required to balance? How can this be demonstrated? Now I will show a few demonstrations to answer these driving questions. This is the first demonstration. This is a PASCO stability model. As you can see, this pin here in the center represents the center of mass. And the center of mass is where all the mass of an object is distributed evenly. From this point, an object can be perfectly balanced, and if suspended from this point, it will also be balanced. In this position, it is balanced. There are two requirements for an object to be balanced. The first is transitional equilibrium, which means zero net force. The second is rotational equilibrium, which is zero net torque. In this position, both of them are zero, so that means it will be balanced. If I were to flip this system around, you can see the arrow falls outside of the block. It is still at transitional equilibrium, but now it has some net torque. So if I were to let it go, it would rotate around the point. This is the second demonstration. As you can see, I have this wooden block. The center of mass of the wooden block would be somewhere here. And when I balance it, and when I try to balance it like this, the center of mass does not fall into the base. So that means it will have net torque acting on it, and it will fall. Now I'm going to use the magic of physics. I'm going to use this wine bottle to balance the block. This wine bottle also has a center of mass. And with the two center of masses, if I can find the center of mass of both of them combined, it'll fall into the base and then balance. Let's see. Now onto the third demonstration. I'm sure many of you have seen this before. The center of mass within this bird is in the beak. As you can see, it balances on my finger. This is because the mass distribution within the bird is all into the beak. So as long as you hold it from the beak, it will be balanced. This is my fourth experiment. This one you can do with your friends. Get an empty Coke can and try and get them to balance. Of course, you're not going to be able to do this. No matter how many times they try, it's always going to fall. This is because the center of mass of the Coke can is here in the center. And if you were to balance it like this, there's nothing to support it. But bet that you can do it. Fill the Coke can with 1/4 of water. And then amaze your friends. This is because the water that you added adds more mass. And instead of the center of mass falling this way, it now falls here into this little area where the water is. And there you have a base to support it. So then it does balance. Here's another experiment. For this experiment, you're going to need string, a ruler, and a regular hammer. Now, I'm going to be able to balance these objects upon this bar. First, you take the ruler and you slide your string after you've made a loop with it. You put it somewhat almost to the edge, and then you slide your hammer in. Now this is going to be tricky because you have to keep moving the string forward until it's perfectly balanced. There. There you go. This system is special because it has two pivot points. There is one here on the bar and another one acting here. Now, the way the hammer balances is the center of mass is going to be somewhere right here. This center of mass is pushing clockwise. Now the ruler is what's stopping the hammer from rotating all the way around. The ruler is applying a normal force upon the hammer. These two balance out, and therefore this one is balanced. Now for the second pivot, there are two forces acting on it. There is tension that is going downwards, and there is the hammer that is trying to go upward. Both of these forces are creating torques, and since they're going in the opposite direction and they're equal, this allows the system to be balanced. this is my last demonstration. Ask your friends if they can balance 12 nails on this one nail. I bet you most of them will be able to do it. I would think most of your friends would try and balance the nails such as this, but you cannot do 12 nails that way. Here, you're going to lay one nail down and then several nails alternating heads across the one nail until you only have one nail left. Take the last nail and stick it through the opposite way of the bottom nail and hold it really tight. Now, try and put it on the center. The system is balanced because there are 5 nails on each side. As the center of mass falls along the bottom nail, then the center of mass of the bottom nail is in the middle, right where you put it on top of the other nail. The concept of center of mass has been around for many, many years. The most common example is in architecture. So the most famous example is the Tower of Pisa. I don't know if you know this, but the Tower of Pisa isn't straight. It is actually tilted on the ground. The reason it is because it was built on soft ground, and when the rains came and made the ground softer, the tower started leaning. The reason it hasn't fallen over is because the center of mass still falls along the base of the tower. Thank you for watching, and if you want more information, you can visit my webpage.